Hello everyone, let's discuss another statement of transformer as a phase shifting device. We have justified transformer as a negative feedback device. Now it's time for transformer as a phase shifting device. So for that, we know that statically, which is nothing but what? Rate of change of flux linkages, right? Rate of change of flux linkages, which is nothing but what is the formula? Minus n d5 by dt. And we know that what are the types of statically induced EMF? E self and E mutual. So from now onwards, E self should be equals to E1, like that E mutual should be equals to E2. This is the simple notation for us. For that, E self should be notated as E1, like that E mutual should be equals to E2, right? So what is the flux? Phi, which is equals to phi m sin omega t, phi m sin omega t. Then what is E self formula? Then E self, what is E self? Which is equals to same amount of, let us say, N1, right? Because the excitation is present in the N1 number of turns, that's why N1 into same amount of flux is induced or developed. We all know that from this minus n d by dt of phi is nothing but what? Phi m sin omega t. So from this minus n1 phi m omega cos omega t. So in order to get sine terms, the cos should be written as 90 minus omega t. So E self, which is equals to E1, which is equals to, in order to eliminate this negative sign, let us write n1 phi m omega sin omega t minus 90. So from this, what we have observed? What is the observation? Here the phase angle is what? Minus 90 degrees. That is EMF lags flux by 90 degrees. Therefore, you can write that statement with a blue marker. Therefore, E1 lags phi or phi m by 90 degrees. That is the angle between E1 and phi m should be equals to 90 degrees. This is very important observation as of now, right? Next, flux and this is the relationship between flux and EMF, clear. Next, self-induced EMF should be written as minus n1 d5 by dt, right? Minus n d5 by dt, which is equals to minus n1, can we write d5 by di into di by dt, of course. So what is the formula for minus n1 d5 by di, which is nothing but minus L self di by dt. Why it is like that? Minus n1 d5 by dt, which is nothing but L self, right? It is nothing but self inductance. So from this What is the observation? E self, which is equals to E1, which is equals to minus L self di by dt. We know that I is equals to what? Time varying nature of current, so which is equals to Im sin omega t. Then substitute this. E1 should be equals to minus L self d by dt of Im sin omega t. So obviously from this we are going to get minus or plus L self Im omega sin omega t minus 90. So from this, what is the statement? E1 lags by 90 degrees, right? Angle between E1 and, or simply you can say current, okay, which is equals to 90 degrees. This is, let us take, this is 2 and previous one, this is 1. So see, the angle between E1 and phi m is nothing but 90 degrees. Like that, the angle between E1 and current is 90 degrees, which means what? Simultaneously, both voltage and flux develop instantaneously, right? Simultaneously, or you can write that from 1 and 2 is displacement between flux and current is 0. The phase displacement between flux and current is 0. That is the angle between flux and current, which is equals to 0 degrees. 0 degrees. Which means what? Sorry. Which means what? Which means both current and flux occurs simultaneously without any delay. That is the meaning. Both current and flux occur simultaneously without any delay. This is very, very important observation. So we have got the relationship between EMF and flux, like that EMF and current, flux and current. Okay. Next, the current through the coil lags the voltage by 90 degrees. We all know that because transformer is inductive circuit. Current through the coil lags the voltage by 90 degrees, as self-induced EMF in the coil does not allow sudden changes in current instantaneously, right? We all know that, as self-induced EMF in the coil does not allow sudden change in current instantaneously. That is, what is the phase angle between voltage and current now? Applied voltage, let us say V1 and I should be equals to what? 90 degrees. Current lags voltage by 90 degrees. Lags. like that between current and EMF 90 degrees. Already we have derived this condition, right? E1 and I is nothing but 90 degrees. EMF lags current by 90 degrees obviously. Therefore between voltage and current 90 degrees, between current and EMF 90 degrees obviously, between supply voltage and induced EMF is nothing but 180 degrees. 180 degrees. This is the justification for transformer as phase shifting device. Transformer as phase shifting device, that is supply voltage and self-induced EMF are opposite to each other. That is V1 which is equals to, opposite means what? 180 degrees, right? When it is 90 degrees, oppose the changes. When it is 180 degrees, opposite to each other. That's why V1 which is equals to minus E1. This negative sign represents what? Opposition, right? That is self-induced EMF opposes the voltage but not the changes in voltage. Self-induced EMF opposes the voltage or opposes the supply voltage but not the changes in voltage. Very important observation. It has to oppose the supply voltage only but not oppose the changes in supply voltage. Obviously this is the justification for transformer as phase shifting device. So like that we have derived the condition between supply voltage, induced EMF, flux and current, like that for mutual inductance. Similarly for mutual induced EMF, what is the formula for mutual induced EMF? EM which is equals to, let us take E2 which is equals to minus N2 d phi by dt. We all know that E2 which is equals to what? Minus M di by dt, sorry, yeah, di by dt with respect to current and with respect to flux. With respect to current, where phi is equals to what? Phi m sin omega t. I like that. I is equals to what? Im sin omega t. So by substituting these equations into this, obviously we are going to get the conditions what? E2 which is equals to minus N2 phi m omega sin omega t minus sin t, like that. E2 which is equals to minus mutual inductance into T, sorry, this is M omega sin omega t minus, sorry, current Im, right? From these two, what we have observed? From this and from this, the angle between E2 and phi 2 which is equals to what? 90 degrees. From this, the angle between E2 and I current, sorry, it's not phi 2, it's flux only, which is equals to 90 degrees. Same like that self-induced EMF, right? That is mutual induced EMF flux by 90 degrees, right? Like that, the angle between flux and current is always 0 degrees. Clear? Similarly for E1 and E2. So from this we can conclude that what is the phase angle between E1 and E2? That is, we can write that, therefore EM lags by 90 degrees. Like that, EM lags current by how many degrees? 90 degrees. Therefore the phase displacement between E self and E mutual is what? 0. Therefore phase displacement between E self and E mutual is 0, that is E1 and E2, which is equal to 0 degrees. What is that meaning? Both EMFs occur simultaneously without any delay. So between voltage, between current and flux, there is no delay. Between two EMFs, whether it is self or mutual, both EMFs are occur simultaneously. So what is the condition? The V1 which is equals to minus E1, right? This is the basic scenario. This is what supply voltage. This is what induced EMF with respect to excitation, same coil. That's why V1 is equals to minus E1. It is equals to what? That is the angle between V1 and E1, which is equals to 180 degrees. Right? Justification for transformer as phase shifting device. Now we have to draw the waveforms. First, before drawing the waveform, we have to write the conclusions. We all know that supply voltage, later we have, let us take magnetizing component of current, then we have flux, then we have induced EMF E1, later E2, right? Then we have to write the phase displacement between current and between these two, 90 degrees, between these two, 0 degrees, between these two, 90 degrees, like that, between these two, 0 degrees. So like that, between I mu and phi m is 0 degrees. Yeah, between these two, (180°), right? That is V1, which is equals to minus E1. This is very, very important. This negative sign is nothing but what? Oppose the supply voltage. This induced EMF is oppose the supply voltage, not opposing the changes in supply voltage, it has to oppose the supply voltage, that is 180 degrees. It is opposing the changes is nothing but 90 degrees, that is Lenz's law, right? This is a very important conclusion from this lecture. Now we have to draw the waveforms. Okay, first I would like to draw supply voltage. Supply voltage. The supply voltage, let us take V1. Okay, next after getting supply voltage, after 90 degrees of phase displacement, current is developed, that is current lags supply voltage by 90 degrees, right? Now it's time for, this is the 90 degrees, right? Clear? This is current, this is I mu. Clear? Next, after simultaneously we are going to get the flux, because the phase displacement between current and flux is nothing but 0, right? Or you can choose different. There is no phase displacement between flux and so this is what? Flux. Clear? Right? Then after 90 degrees of phase displacement of flux development, an EMF will be induced, that is E1, obviously, which is nothing but opposite to supply voltage, which is opposite to supply voltage. So obviously exactly opposite to supply voltage. This is what? E1. Obviously this is E1, so obviously simultaneously we are going to get, we don't know whether the magnitude is same or not, that's why, but these two are in phase with each other, because E1 and E2 is nothing but, this is the graph for that, between supply voltage, current, flux, induced EMF, the self-induced EMF, mutual induced EMF. These are the phase displacement between either two quantities. So from this we can draw phasor diagram of transformer, or we can say that ideal transformer under no load condition. So we can say phi, which is nothing but phi m sin omega t. This is taken as reference. With respect to this reference, we can draw the phasor diagram. Okay. What is the reference? Phi m, right? So this is phi m. Clear? So what between supply voltage and phi m, what is the phase displacement? Between supply voltage and phi m, what is the phase displacement? 90 degrees. So phi m lags V1 by 90 degrees. So now supply voltage is what? Leads. This is V1. The phase displacement between two is nothing but 90 degrees. Clear? Supply voltage leads phi m by 90 degrees. We don't know the exact magnitudes, that's why this is taken as reference. Clear? Again, V1 and phi m is completed, but coming to I mu, the phase displacement between I mu and phi m is nothing but 0. So obviously I mu is in phase with I mu is in phase with flux, because the phase displacement between I mu and phi m is nothing but 0. Satisfied. Next, later, what about E1? After 90 degrees of flux development, an EMF will be induced. So obviously this is the value of E1. This is the phase displacement. So obviously simultaneously we are going to get E2 also. E1, E2. E1, E2 are in phase. I mu phi m are in phase. Phi m lags V1 by 90 degrees. Like that, E1 lags phi m by 90 degrees, or E1 lags I mu by 90 degrees. So this is the phasor diagram of ideal transformer under no load condition. Under no load condition. This is very most important. Simple. Just go through this derivation once, then you have clear idea about the phase displacement between different quantities and the relation between these quantities. Thank you.